on this slide, you will see the standard equation of a circle. So what do you need to write the equation of a circle? First, you need the center. And the center is given by the coordinates h and k. Now, these variables could be any number. It can be a combination of two positives, two negatives, depending on where the center is at, depending on the quadrant that contains the center. Now, this point here, xy, could be any random point on the circle. It doesn't have to be here. It could also be at this spot right here. So that could be your xy, yeah? As long as it is on the circumference of the circle. Okay, so if you want to get the radius, you can actually find the radius by using the distance formula. So we know that the distance formula is given by the square root of, and then you pair the x coordinates up, but the x coordinate is here, that's x, and then the x coordinate here is h. So we put x minus h squared plus the y minus k squared. So this formula is similar to what we have over here, but where did they get the r squared from? So if you square both sides of this equation, you'll get d squared equals, now if you square this one, the radical sign will go away, and then you'll have x minus h squared plus y minus k squared. So this is an alternative way of deriving the equation of a circle, and since the distance between the center and any point in the circle is a radius, then we can replace the variable d by r to represent the radius of the circle. Well, what if the center of the circle is 0, 0? What happens? Is that possible? Well, if your circle is centered at the origin, which is 0, 0, then the values of h and k here will just be 0. So using r now instead of d, the equation will be r squared is equal to, pretty much it will become x minus 0 quantity squared. But what is x minus 0? It will just become x. So that will be r squared is equal to x squared plus y squared. So let's play around with some values of r here. To do that, go ahead and open decimals. So go to decimals and try typing x squared plus y squared is equal to 4. So this means that the circle is centered at the origin, right? But it doesn't mean that the radius is 4, because in the formula it said r squared, so the radius is the square root of that. And I'm showing you that, I'm emphasizing that because there's a lot of misconception regarding the number or the constant in the equation. So the radius is not 4, instead get the square root, so 2. So as you can see in our graph, this is at 2, so don't count the number of boxes, but so this is 2, so that means the center from, or the distance from the center to any point on the circle is 2 units. Okay, now let's type in, or let's change that to a bigger number. Let's say we want the radius to be 3. So if you square 3, then you're going to get 9, right? There you go. So that's 1, 2, 3. So the radius is 3, but in the formula you have to put it's a squared version, so 9. Well, is it possible to substitute a non-perfect square number? Yeah, sure. Let's say this is the squared version, so 7. So then what is the radius? In that case, the radius will become r is equal to square root of 7. So you can change that to a decimal and give the approximate value. If the circle is centered, let's say at 2, 1, how are we going to enter it? Let me just unclick this one and delete our marks. Okay, so let's say I have x minus 2 squared plus y minus 2 squared, let's just use a small radius. Let's say the radius is 2, so I'll put 4. Okay, so take note that it doesn't mean that the circle goes to the negative quadrant. No. If you get the opposite of -2, that's +2. And then similarly, the opposite of -2 here is +2. So when you're plugging in into your formula, be careful, because if the center here is +2, I should write it down. So the center of the circle is 2, 2. And since the formula is x minus, so minus times the positive of that, it becomes -2. There you go. Plus y minus, and then that's also a positive, so negative times positive is negative squared is equal to 2 squared, right? But the 2 squared is the same as the 4 squared over here. Okay, so what will happen if, let's unclick that. So what happens if you have x plus 1 squared. Okay, bear with me here. It's kind of hard to toggle between the mouse and the keyboard. So y minus, no, let's put plus 3 squared equals, let's say we want a radius of 3, so square 3, we get 9. So where is your circle now? So your circle has a center where? So from these numbers here, your center is, you get the opposite of this one, right? Because the formula was x minus of something. So the opposite of +1 is -1. And then y minus something, so that missing number is -3. So let's see, let's verify that. This is -1 and this is -3. So that's your circle. Now the radius here is 3, which is the square root of 9. So if we count from the center, that's 1, 2, 3, right? So because every 2 boxes is 1 unit. Alright, so that's how you find the center and, the radius of the circle, and that's how you substitute them into the equation. Now let's use what we just learned to answer some examples. Write the standard equation of each circle. First, the circle shown at the left. So first, what's the center? The center here is 0, 0. So that's your h, that's your k. Now what's the radius? So if this is 2, so each line corresponds to 1 unit. So the radius is 1, 2, 3. So to write down the equation, oh, I forgot to put r equals 3. So the equation is x squared plus y squared is equal to r squared, right? Because it's centered at 0, 0. So x squared plus y squared, substitute the value of r, which is 3, and then you square 3, you will get 9. Okay. Now in letter B, what if you have a circle with center 0, 9 and a radius 4.2? So this means that we're going to use the formula that has h and k. So let me write it down. X minus h squared plus y minus k squared is equal to r squared. So plug in the values. This will become x minus 0 squared, but if you clean that up, that will just reduce to x squared plus y minus -9, so the two negatives will become positive. That's a 9 because 7 is equal to 4.2, which is the radius, and then you have to square that. So if you clean this up a little bit, you'll get y plus 9, don't forget your grouping symbol, is equal to 4.2 to the second power. There you go. You may also square 4.2 and write down its final form. In this example, the value of your h is -1, so it's going to be x minus -1, so that turns to +1 squared, plus y minus 3, so -3 to the second power. So A useful shortcut is you actually plug in the opposite of the value of the center. So the -1 turns to +1, the +3 turns to -3. Now you can do this in two ways. You can count how many units a point on the circumference is, like away from the center. So that's 1, 2, 3, 4, 5. Or you can actually find the distance between the given point and the center by using the distance formula. So if you do this distance formula, you'll get 6 minus 3 squared. Let me redo that. Okay. So you get 6 minus 3 squared plus -5 minus -1, so that turns to +1 squared. Now 6 minus 3 is 3. If you square 3, you get 9. So this is the square root of 9 plus -5 plus 1 is -4. If you square -4, you'll get positive 16. So this is equal to 25. But the square root of 25 is 5. So take note that that's the same as when you count the boxes or number of boxes from here to the edge or circumference of the circle. There you go. So going back here, the radius is 5. So if you square 5, it will become 25.